Hi everyone, in this video we're going to prove that the union of two compact subsets of a topological space is also compact. Let's just go ahead and jump into the proof and we'll talk about the definitions as we go through it. So proof. So we'll start the proof by letting capital X be a topological space. So let capital X be a topological space. Topological space. And we need two compact subsets. Let's call them A and B. And A and B, subsets of capital X, where A and B are compact. So A and B are compact. So we have to show that the union is compact. So the claim is that A union B is compact as well. So to show us that it's compact, you start by taking what's called an open covering of that set, like this. So let O sub alpha, where alpha runs through some index set, be an open cover for A union B. That means that A union B is contained in the union of these guys. Okay, so to show it's compact, we have to show that A union B is contained in a finite union of these guys. That's the key. So to show us that it's compact, you start by letting it be contained in some union, which we're going to write down in a minute. And then you show you can find a finite number of members of that union such that the condition is still true. Okay, so what does this mean? So this means that A union B is contained in what? Well, it's going to be contained in the union of the O alphas. So O alpha, alpha, and i's. This is what it means for this to be an open covering of this. Okay, now we have to find a finite subcover of this. So to do that, we have to somehow use the fact that A and B are compact. So check this out. So note, A is a subset of A union B, which is a subset of these O alphas, because we just said it was. So this is an open covering for A, but A is compact. So there exists a finite number of these that cover A. So since A is compact, it's really a nice proof. It's not so bad. We have that A is contained in the union of, let's say, O alpha I, as I runs from 1 to n. Okay, so A is contained in those. Likewise, B is contained in A union B, which is contained in the union of the O alphas, as alpha runs through some index set I. So since B is compact, I have to be really careful with the notation here. Compact. I can't use this same notation here, so I have to use something different. I haven't decided what yet. We'll figure it out. I'll figure it out. So let's see. I don't want to start at 1, so I'm going to do this. I'm going to do something like this. I'll use J. I'll start at 1, but I'll be abusive here. I'm going to use a different letter. I'll call it beta 1, just beta J, where, let me just specify, where O beta J, I'll just do this, where beta J is an I, just to specify that they're not necessarily the same. They're just completely different, right? You want to make sure that things are different. I could have used another subscript here. I could have done like O sub alpha sub A sub I. And then I could have done like O sub alpha sub B sub I or something like that, but it doesn't really matter. In this case, it's correct and it's clear because these are different and we're specifying it's still part of this infinite family of open sets. So we have that A is contained in this and B is contained in this. So that means that A union B is contained in, well, A is contained in these guys. So this will be parentheses union I runs from 1 to n, O alpha sub I, then union, and then B is contained in these. So this is the union J equals 1. I use the same letter here, N. I'm going to use M here. I'm going to go back and change that. just to really make it different. And then this here would be OBJ. There we go, beautiful. And this is a finite subcover of our original covering. So we have A union B contained in some arbitrary union of open sets, and we found a finite number of those open sets such that A union B is still contained in that union. That's precisely what it means for A union B to be compact. So A union B is compact. Compact. And that completes the proof. So I think the trickiest thing maybe is here is just being really careful with the notation, right? You want to make sure that everything makes sense. I hope this video has been helpful. Take care.